Hi everyone, in this video we'll have a look into the rate of change of volume due to a non-uniform velocity field. So let us consider the same example of a cube in a coordinate system x, y, z. Okay, so if this length is dx, we have already seen earlier that the elongation of length in the x direction is given by delta x 1 plus del u del x delta t. Similarly, the elongation in the y direction is given by delta y 1 plus del v del y delta t, and the elongation in the z direction is given by delta z 1 plus del w del z delta t. And so we have the initial volume delta x, delta y, delta z, where this length is delta y and this length is delta z, and the final volume is the product of this 1, 2 and 3. So the final volume is equal to delta x, delta y, delta z 1 plus del u del x delta t 1 plus del v del y delta t and 1 plus del w del z delta t. This is equal to delta x, delta y, delta z 1 plus delta t multiplied by del u del x plus del v del y plus del w del z plus delta t square del u del x del v del y plus del v del y del w del z plus del u del x del w del z plus another term delta t cube del u del x del v del y del w del z. And so clearly the final volume minus initial volume is equal to, so this final volume minus initial volume, this delta xyz and this delta xyz multiplied by 1 will get cancelled, and we have delta t, delta x, delta y. So the second term is this. So this first term gets cancelled with the second term is this delta x into delta x, delta y, delta z multiplied by del u del x plus del v del y plus del w del z. So d volume by dt 1 by v is basically 1 by delta x, delta y, delta z limit delta t tends to 0 delta v by delta t. So this is delta v, we have delta t over here, so we have delta t by delta v by delta t over here and 1 by v, so this term is v. So using this equation and this equation we obtain delta v by delta t 1 by v limit delta t tends to 0 is equal to del u del x plus del v del y plus del w del z. Okay, so physically the meaning is the rate of change of volume is due to the three linear deformation components, the sum of three linear deformation components. And if we have 1 by v dv dt equal to 0, it means that volume is not changing of a fluid element is not changing. Of course, the fluid element is allowed to deform. It can still deform, but the volume is not changing. So, in such a case, from this equation we see that del u del x plus del v del y plus del w del z is equal to 0, which implies the divergence of the velocity vector is 0. The divergence of any vector v is equal to del v1 del x plus del v2 del y plus del v3 del z, where the vector has components v1, v2, v3. So if v is equal to the velocity, we have del u del x plus del v del y plus del w del z. Okay. Alternately, the divergence of the velocity can be written as this nabla dot v, and this is also equal to del u1 del x1 plus del u2 del x2 plus del u3 del x3. So an incompressible flow if and only if the divergence of the velocity is 0, that is, the volume of a fluid element does not change because of the non-uniform flow field. The elements can deform, but the volume of the element remains constant. So if this is equal to 0, the flow is said to be incompressible. So this is different from a fluid becoming incompressible. If a fluid is incompressible, it means the density does not change with increase in pressure. Okay, so this is a very subtle point.